Hello everyone, my name is Pulkit Jain. I am a fourth year undergraduate student at Bennett University. Today I am going to demonstrate my project in the coursework of Advanced Database Management System. The project title is Index Implementation Using B plus Trees in Relational Database Management Systems. It is a research based project which is intended to show that how the B plus trees indexes can be created in a database and how creating them reduces the searching, insertion, and deletion time complexity of a database to 5 to 6 orders of magnitude. We will also do a comparative study between the traditional table scan method and the index seek method, and we will see the differences in the output results. So we will create our own database, we will create indexes on that database, and then we will perform some search queries on the database and see what the results are outputted from those queries. Okay, so let me fire off this code. I press the run button, proceed. Okay, the project is started. So this is the home panel. In this home panel I have given a brief description about the project. So in this project I am making a software which will make searching in a relational database management system optimized, as well as we will also show better performance of index seek method over table scan method. Right, so it is a brief description. Now let us go to the data panel. So in this data panel I have to tell that how many rows I have to put into my database. So let us see that. Okay, this is the folder section. So this is the project section where the database will be created. So let me just write, let's say I want to create 10,000 rows. Okay, so I fire off create test data and the data is created successfully. Okay, so if you go to the project folder, the data folder is created, and the data folder consists of extents, and each extent consists of 8 pages, and each page is of 8 kilobyte. Okay, and these pages contains the actual data. So let's see the data. Okay, so this is the actual data. It consists of four pipe separated values. The first is the enrollment number, the second is the name, the third is the username, and the fourth value is the password. Okay, so these values are randomly generated by the computers, these names, and this is the data of the page. And if you will see that every extent has the same method, 8 pages, and each page of 8 bytes, and at the end this is the page 5. It may not contain, it may not be of 8 kilobytes because it is the last page, and it contains the data till the 10,000 rows. Okay, now let me tell you that what happens in the table scan method. So suppose I want to search some data. Suppose this is the data. I want to search this name, PXOTWAMMPRW. So what happens that if I put this value, that I want to search this value, so CPU will fetch each page from the hard disk into the main memory, traverse through the whole page, and check that if the name value of every page of every row matches my desired value, and if it matches, it will return the output record, this record. So it will do this for every page and for every extent. So it is a quite expensive process and it will take a lot of time, right? So we will see that how we would optimize it. Okay, and this is the last file. This is the metadata file. So this metadata file consists of only the number of rows. It is required because it helps us in creating index. It will be used in creating the indexes. Okay, so we have seen the data. Now let us create the indices. So this is the indices panel, and I have to select that on which column I need to create my index. So as there were 3 columns, name, username, password, so I can create index on anyone. So let me put name, and I fire off create index button. Okay, so the create index will take some amount of time, and as you can see that I can go to any other panel while the index is being created, because I have used multi-threading in this project, so that if one process is going on, I can still do other processes while doing both simultaneously. Okay, so indexes created successfully. Okay, so in this project folder, indices are created. So the indices are created on the name column as we have put in it, and these are the index pages, right? And these pages consist of the are named by random UUIDs. Okay, and this consists of leaf page and non-leaf page. So let us first start with the metadata file. What is it? So this metadata file, as you can see, it consists of two values. The first one is the UID of those pages that we have seen, and second is a Boolean value. So what this tells us that those pages whose Boolean value is true are leaf pages, and those pages whose Boolean value is false are non-leaf pages. So why do we require these the different things, that leaf pages and non-leaf pages? What is the difference in them? We will see now. So let us go to first the non-leaf page, which is the root. Since there were less number of rows, there were only 10,000 rows. That's why there is only one non-leaf page and every other is leaf page. So let us see the non-leaf page root. So this is the root page, and as you can see that it consists of a value which is the name value, and it consists of two other pipe separated values. So yeah, as you might have guessed, these are the UIDs of those pages. So what it is showing is, suppose that I have selected this value, that's BND and so on. So it is showing that this page E1B, this page and its subtree consists of the values that are between this ATH and this B and D value, while this page, this is the next child page, it consists of the values and its subtree consists of the values starting from B and D and go till CGL. So I have used like two pointers, one is the previous child pointer and one is the next child pointer. For every page I can use only one pointer also, but I have decided to go with two pointers approach. Okay, so these are the child pages that contains the value up to this node and so on, and this is the child page that consists value up to this node and this value, right? So that's why these both are same, as you might have seen. So let us see this page. Okay, as I've said, E1B 823. Okay, so E1B 823, this was the page, right? So as I've said, it consists of the values from ATH up to B and D. So it consists of the value from ATH up to before B and D and that last value. So this is a leaf page. Now you have seen the difference between the non-leaf page and the leaf page. Non-leaf page contains the pointers to the other child pages, while the leaf page contains to the pointers of the actual data, right? So this what is the record means that this ATHT it is present in extent number 2, page number 7 and row offset number 106. So it is a dense index. It consists of every value and its record in the actual data pages. So this is the address of the data page, right? So what happens in the index seek method? Let's suppose I want to find this name value, that BEVS PLAST. So what happens that first of all my pointer will go to the root page. It will find a value which is greater than my desired value, BVS PLAST. So it goes to A, okay, it is smaller, and then B and D, okay, it is greater. So since it is greater, it will go to its previous child page, right? It will go to this child page and it will start traversing this child page from beginning till the end, and it will see that, and it will match every value from a desired value and will say that okay, this value is found, BS desired value is found. So it will go to the extent number 3, page number 5 and row offset 84 and give the desired record that we wanted to find, right? So you see that we have eliminated all the other possible opportunities where the data could be found, right? Like these all the index pages and this the beginning index pages, we are not traversing them because of these indexes. So this is the this is the optimization that we achieve through having B plus trees, and the complexity reduces to log m, where m is the degree of the B tree, because now we are seeing only two pages, right? One child page, one is root page, another is the child page, right? So then we will see that how it is actually done by the computer when we do the search query. So this was the overview that how we can do this using B plus trees. So let me show you by doing this. Suppose okay, I want to find some value. Let's go to the databases. Suppose extend 4 page 4. Suppose I want to search this value ZMXK. So I go to the query panel. Query panel is select star from table where name equals to this. So we have created since indexes on name. So let me put the search button. So that's why the search method is index seek. The time taken is 10 millisecond and the pages read are 2. Right, and this is the actual data, the actual record data that we want to find. Roll number is 6078, name is this, username is this, and password is this. Yeah, so roll number is 6078, name, username, and password. Right. Now suppose that I do query on the same record using username. Username is a non-index field. We have not created indexes on username, right? So let me search the same record, which is old username. So I click on search button. So as you can see, the method that is used is table scan, because we have not created index on this. The time taken is 26 millisecond and the pages read are 27, and it outputs the same record. So as you can see, the difference between the index seek method and the table scan method, that the time taken in doing these two things has reduced to 5 to 6 orders of millisecond using the index seek method in comparison with table scan method, and the pages read are so much less. So in case where there are so many values and there is a huge database, so this index seek method reduces the complexity a whole lot, and it optimizes our database, and it is a very efficient approach to these things. Right, so we have done a comparative study of both the indexing method and table scan method, and we have seen that how the indexing method has a whole lot of advantages over the table scan method. Right, so that was it. Thank you.